Assalamualaikum and hi doctor. My name is Muhammad Sufyan bin Jalil from AS 2515D1 and my partner is
Assalamualaikum warahmatullahi wabarakatuh. My name is Arena Valerie binti Othman.
and for this video we are going to present the experiment 3 which is characterization of PV module.
Experiment 3 is about the characterization of PV modules. The aim of this practical is to investigate the electrical characteristics of PV module. And the objectives are: first, to determine the IV curve characteristics of a PV module. Second, to determine the PV curve characteristics of PV module. Third, to determine the fill factor of the PV module. And lastly, to determine the conversion efficiency of the PV module. So, behind the theory of this experiment, usually a PV module is characterized using the current voltage performance of a string cells in the module. So, in order to find the current voltage performance of a string is basically using the IV curve and power curve. And the IV curve and power curve are valid at particular irradiance and cell temperature only. So that is what we find in this experiment to plot IV curve graph and power curve graph. As what you see in screen is the three graphs that should be plotted. This is the figure of the theoretical graph. From the left is the IV curve graph, and then the power curve graph. And third is where the IV and PV curve have been plotted. The equipments needed for this experiment are connection cables, switchboard, rheostat, PPE, personal protection equipment such as sunglasses, hard hat, and gloves. Next, we need solarimeter, clamp meter, temperature gun, multimeter. Now we're moving on to procedures on how this experiment has been run. So first, we place the solar PV module horizontally and place pyranometer next to the PV module facing to the sun. Next, we have to set up the circuit as in manuals. And then, we have to make sure that the right connections have been connected to avoid electrical shock. After the right connection has been made, firstly, we have to find the value of short circuit current at where the rheostat is at 0. And then, after finding the short circuit current, then we find the value of open circuit voltage where the rheostat is at maximum. Next, we determine the interval reading between the minimum and maximum, and we find IMP and VMP. In order to do that, we have to move the rheostat a various position from the minimum to the maximum. And after that, we record every readings to the maximum. And after recording, collect the data and then plot the graph. Solar irradiance and the temperature of PV modules are also determined.
We move to data and results. This is the characterization of PV module set 2. Table 3.1 is the datasheet at STC and set information, and then for table 3.2 is measure data, and the last one is table 3.3 experimental data. This is graph of current voltage and power voltage curve of a PV module. X is Y and X was labeled. The orange line represents power maximum, blue line is a short circuit current, dot line is a current at maximum power, and green color represents voltage maximum. We move to analysis of graph. Based on graph, PV module is characterized based on current voltage performance of a string of cells in the modules. Next, current voltage and power voltage curve was used to characterize the current voltage performance, but only current voltage and power voltage curve valid at particular irradiance and cell temperature. Here, the electrical performance of the solar cell and PV module, which are power maximum, open circuit voltage, short circuit current, voltage at maximum power, and current at maximum power. From the data, we found that the value of maximum power is 147.4 0.46, short circuit current 4.0 voltage at maximum power 147.46. Open voltage current is 44.05 volt and current at maximum is 3.65 ampere. Next is calculation. This is the formula that we are using to find fill factor. We just put the value into the formula and we will get the answer for the datasheet and experiment fill factor. This is the formula to find efficiency of conversion. For irradiance, we sum up all the value of irradiance from experimental data and then we divide it by 20. This will get the value of midpoint. For area, we times the length with width, and lastly we will get the value efficiency of conversion of datasheet and experiment. For discussion, the aims was to investigate the electrical characteristic of a PV module, the current voltage, performance of string of cell in the PV module was observed and characteristic of the PV module was determined based on the observation. Based on observation, and current voltage curve graph and PV curve graph was able to be plotted and were utilized to characteristic the current voltage performance. Other than that, from table 3.2 and 3.3, notice that the voltage decreased as the temperature increased. From that, we can draw a hypothesis whereby the relationship of the voltage is inverse with the current and temperature. Furthermore, as the current increases, the resistance decreases. In this experiment, the rosette was moved to different positions to get a varying resistance reading and varies. This was done to obtain a set of current and voltage reading to plot the current voltage curve. All readings were recorded in table 3.3. Next, table 3.1 was information of the datasheet and information regarding the site of the PV module. The maximum power is 345, open voltage current 46.37 volts and short circuit current is 9.67 ampere. The experiment was conducted at Makmal Lapangan FSY, berhadapan College Anggrek with latitude 3.04010 and longitude 1.0.2936 during the evening. For table 3.2, it illustrates the measure data of the beginning and ending of the experiment with the parameters solar radiance and PV module temperature. The experiment was conducted from 14:20 p.m. to 4:25 p.m. with total duration of the experiment is 5 minutes. Table 3.3 records the data regarding the variable resistor setting, irradiance voltage, current and power. From the graph, the orange line here represents the current curve, the current voltage curve, while the blue line represents the power voltage curve. From the current voltage curve, it was possible to determine the power maximum, which is the highest point of the graph, by combining of two graphs, drawing a vertical line down from the power maximum point, the voltage power maximum obtained with the value of 40.40 volts, and drawing a horizontal line until they intersect the vertical line. The current power maximum was obtained at value of 3.65 ampere. By obtaining these 5 parameters, the fill factor and convention efficiency were calculated. The fill factor represents the measure of sequences of the current voltage curve as shown in graph. Next, the irradiance value used to calculate the efficiency was the average irradiance measured during the experiment. The value of fill factor is 0.8369 and the convention efficiency is 0.1705. Precaution steps had been taken to obtain the maximum amount of solar irradiance. The PV module used must always face perpendicular to the sun. By doing that, it was possible to obtain the best solar irradiance reading. Other than that, the experiment must conduct quickly as the reading temperature and irradiance may be fluctuate, and this will lead to the wrong analysis current voltage curve and power voltage curve characteristic. To sum up, the characteristic of the PV module was able to investigate the current voltage and power voltage graph were plotted and created, allowing the value of 5 parameters to be determined.